Enceladus is the 6th largest moon of Saturn and the 19th largest in our solar system. It is about 500 kilometers, or 310 miles in diameter, about a tenth of that of Saturn's largest moon, Titan. It is mostly covered by fresh, clean ice, making it one of the most reflective bodies of the solar system. Consequently, its surface temperature at noon reaches only -198 degrees Celsius, far colder than a light-absorbing body would be. Despite its small size, Enceladus has a wide range of surface features, ranging from old, heavily cratered regions to young, tectonically deformed terrain. Enceladus was discovered on August 28, 1789, by William Herschel, but little was known about it until the two Voyager spacecraft, Voyager 1 and Voyager 2, flew by Saturn in 1980 and 1981, capturing the first pictures of the ice world. In 2005, the spacecraft Cassini started multiple close flybys of Enceladus, revealing its surface and environment in greater detail. In particular, Cassini discovered water-rich plumes venting from the South Polar region. Cryovolcanoes near the South Pole shoot geyser-like jets of water vapor, molecular hydrogen, other volatiles, and solid material, including sodium chloride crystals and ice particles, into space, totaling about 200 kilograms or 440 pounds per second. More than 100 geysers have been identified. Some of the water vapor falls back as snow. The rest escapes and supplies most of the material making up Saturn's E-ring. According to NASA scientists, the plumes are similar in composition to comets. In 2014, NASA reported that Cassini had found evidence for a large South Polar subsurface ocean of liquid water, with a thickness of around 10 kilometers, 6 miles. The existence of Enceladus' subsurface ocean has since been mathematically modeled and replicated. On March 9, 2006, NASA announced that images from Cassini suggest the presence of liquid water in the southern polar region of Enceladus. This water could be located in chambers, possibly just a few meters below the surface, and might erupt to the surface similar to a geyser. Part of the ice particles falls back onto the surface, contributing to Enceladus's notably high reflectivity. A portion of the particles that escape into space reaches the surfaces of other Saturnian moons, causing Mimas, Tethys, Dione, and Rhea, the satellites within the E-ring region, to appear unusually bright compared to other moons. On October 9, 2008, Cassini passed by Enceladus at a distance of only 25 kilometers. This marked the closest approach by a spacecraft in the history of space exploration. During the flyby, Cassini traversed through freshly ejected particles. Two instruments were operational at that time: the cosmic dust analyzer and the ion and neutral mass spectrometer. The measurements revealed a much higher density of volatile gases such as water vapor, carbon dioxide, and carbon monoxide than previously assumed. Additionally, organic materials, previously detected through a spectroscopic analysis of a stellar occultation, were more abundant than expected. The particle density was so high that it exerted a measurable torque on the spacecraft. A surprise came in the chemical composition of the expelled particles, resembling that of a comet. Unlike comets, however, Enceladus is heated from within. Thus, Enceladus possesses warmth, water, and organic chemicals, essential building blocks for the development of life. Cassini also detected hydrogen molecules in the geyser eruptions, suggesting the existence of hot hydrothermal vents on the floor of Enceladus's ocean, analogous to Earth's ocean floors. There are hypotheses suggesting that the first primitive life forms on Earth may have originated near such hot hydrothermal vents. This raises the possibility that life could have originated on Enceladus as well. As for proposed mission concepts, in November 2017, Russian billionaire Yuri Milner expressed interest in funding a low-cost, privately funded mission to Enceladus, which can be launched relatively soon. In September 2018, NASA and the Breakthrough Initiatives, founded by Milner, signed a cooperation agreement for the mission's initial concept phase. The spacecraft would be low-cost, low-mass, and would be launched at high speed on an affordable rocket. The spacecraft would be directed to perform a single flyby through Enceladus's plumes in order to sample and analyze its content for biosignatures. NASA provided scientific and technical expertise through various reviews from March 2019 to December 2019. In April 2022, the National Academies of Sciences, Engineering and Medicine, an umbrella organization for U.S. scientific academies, recommended to NASA, as part of its flagship program, to assign the second highest priority to a mission focused on Enceladus. This mission involves a spacecraft, initially orbiting and subsequently landing on the Moon, known as an Orbi-lander. Additionally, the recommendation emphasized prioritizing a Uranus orbiter mission for the years 2023 to 2032 within NASA's flagship program. The mission, with an estimated cost of $4.9 billion, could launch on a Space Launch System, or Falcon Heavy, although the earliest possible landing of the orbiter wouldn't be until the early 2050s. Thank you for watching. If you liked the video, consider subscribing and leaving a like. Until next time.